Hello everyone, this video shows our recent work published in KDD 2018, EvoGraph, an effective and efficient graph upscaling method for preserving graph properties. Graphs are widely used to model real-world objects in many disciplines due to their simplicity and generality. Graphs are everywhere and there are many representative examples of graphs such as a social network, protein-protein interaction networks, and even neural network. Nowadays, many researchers and industry groups often suffer from the lack of a variety of large-scale real graphs. For example, there are many real-world graph repositories such as Snap, and Koblenz. However, real-world graphs in those repositories is too small. For that reason, synthetic graph is commonly used. Although a lot of synthetic graph generation and upscaling methods, their output graphs tend to be quite different from real-world graphs in terms of graph properties. Gscaler is the state-of-the-art graph upscaling method motivated by DNA shotgun sequencing. Let me briefly explain how to upscale a graph by using Gscaler. It does graph upscaling through the following 4 steps: decomposing, scaling, vertex synthesis, and edge synthesis. Gscaler tends to lose a considerable amount of properties of the real graph due to its decomposing and combining mechanism. The basic idea behind EvoGraph is to exploit the topology of an original graph without any sampling from the graph or any parameterization of the graph. During the graph upscaling process in evolutionary manner, new edge references existing edges in original graph. For the graph upscaling process, we propose the edge-centric preferential attachment, and in order to reduce memory usage, we also propose the memory-efficient edge attachment. Due to lack of the time, we omit the details, please check out our paper. The key idea behind the memory-efficient edge attachment process does not keep the entire generated graph during graph upscaling, and instead calculates the parent edges required for edge determination only with keeping a given original graph in main memory. There are many graph properties that show the unique characteristic of a real graph. In this paper, we focus on the distribution or plot for rich information of graph properties, and evaluate the performance of the upscaling methods. In particular, we use the following well-known 8 graph properties: in degree, out degree, triangle count, hop plot, strongly connected components, weakly connected components, singular values and first right singular vector. EvoGraph outperforms Kronecker and Gscaler by up to 1680 and 58 times. And also, it does not change the memory usage. As a result, without pre-processing and fast generation method, EvoGraph significantly outperforms Kronecker and Gscaler. In addition, EvoGraph shows highly parallelizable and scalable. Since EvoGraph exploits the original graph itself, it can easily preserve the major properties of the original graph. It significantly outperforms the state-of-the-art method Gscaler in terms of preserving 8 widely used graph properties. And it can upscale the graph, which has about 0.9 trillion edges, and still preserve the graph properties. This is an open-source software. You can download source and binary below URL. If you are interested in finding out more about our work, check out our paper. We hope to see you in our presentation session in KDD 2018. Thank you.